Assalamualaikum warahmatullahi wabarakatuh. To Dr. Muhammad ERFY bin ISMAIL and Encik Muhammad ZAKY bin CHUMARI. So today I will present to you about my PSM1 with the title of Effect of Welding Parameters on 3G my steel plate using automated robotic welding process. So my name is Muhammad Ilham bin Sukor and my matrix number is CB210023. First of all, I will present to you about my chapter 1, which is the introduction part. So I will tell you about the problem statement of my study, the objective of my study, the research questions, the scope of my study, and also the study limitation. So first of all, we're going to jump into the problem statement of my study, which is the first one is 3G position. So according to Nguyen et al., 3G position in welding poses a unique challenge because of the impact of gravity on the molten pool, which can result in a deeper weld pool than other welding positions. So secondly, the weld bit shape and penetration depth may be impacted by the molten pool moving away from the arc due to the gravitational effect. So this is according to Nguyen et al. And the third one is welding made with the vertical arc positions such as the 3G position are more likely to contain burn-through holes and undercuts. It is from according to Chang et al. Okay, so for the weld bit problem statement for the weld bit defects, basically the weld bit defects can arise as a result of several factors such as heat input, welding speed, and also the electrode movement. So the second one, according to Singh, weld bit defects like undercuts and overlap can be caused by welding electrode. So for the third one is that finding suitable parameters for this experiment will enhance the quality of the weld bit and decreasing the possibility of defects. For the third problem statement is the root penetration. So according to Wang et al. 2021, precise control of welding parameters is crucial for achieving complete root penetration, where too much heat can cause burn-through, while too little heat can lead to incomplete penetration and weaker joints. So for the last problem statement is the tensile strength. So variability, key welding parameters such as current, voltage, travel speed, and wire feed speed rate has been shown to influence the tensile strength in G-mount joints. This is according to Sarjiana et al. 2021. So the second one is white and soft HAZ, so heat affected zone reduces tensile strength and can cause failure in the soft heat affected zone. This is according to Go et al. 2017. So the last one is, in order to determine the strength of the weld bit, it is essential to choose the proper welding parameters such as travel speed, such as welding current, and voltage. This is according from He et al. 2022. For my objective of study, the first one is to perform a visual test on the weld bit and root penetration to assess its quality. And the second one is to perform destructive tests on the joint using tensile tests to identify the weld tensile strength. And the third one is to determine the most optimum welding process parameters for 3G position on G-mount robotic process. So for my research questions, the first one is what types of weld defects can be identified on the weld bit and root penetration through visual inspection in the 3G position using the G-mount robotic process. So the second one is how does the tensile test reveal the strength and failure characteristic of weld joints in the 3G position using G-mount robotic process. And then the third one is what combination of welding parameters is the most optimum in order to achieve consistent weld bit and root penetration quality and the tensile strength of the joint for G-mount robotic process on my steel plate on 3G position to ensure high quality welds and minimal defects. So for the scope of my study, it only focused on the G-mount robotic process for 3G position on my steel plate. The dimension of the my steel plate is 120 mm length times 100 mm width times 9 mm the plate thickness. So the second one is the weld bit and root penetration quality and the tensile strength. And then the third one is the gas used, which is the carbon dioxide, CO2, welding process, and copper filler wire material with 1.2 mm size. And then the fourth one, the last one, the welding parameter used for this study, current, voltage, and wire feed speed. So for my study limitation, is the first one is my research is only conducted on my steel plate, which may limit the findings to other materials commonly used in welding applications such as aluminium, stainless steel. Okay, so the second one is my research is only conducted on 3G position. So other groove position such as 1G, 2G, 4G, 5G, and 6G may shows different behaviors and response to welding parameters. So the third one, the last one, is that my study is only focusing on weld bit and root penetration quality and also the tensile strength as indicators of weld quality. So other weld qualities such as distortion is not addressed in my study. So we're going to jump straight into my chapter 3, which is the methodology for my research. Okay, so I will tell you about the parameter used, the Taguchi method in DOE, and then the machine selection, material selection, and also the data analysis collection procedure. So the Taguchi method in design of experiment in DOE is that the constant parameter for my study is gas, filler wire size, and also the groove angle. So for gas, I'm going to use carbon dioxide gas, and then the filler wire size is 1.2 mm, and then the groove angle is 45 degrees. Based on the Taguchi method, it only needed 9 specimens for the experiment. So the welding parameter that I will be using for my first specimen is 60 amperage, 16.8 voltage, and 1.7 meter per minute wire feed rate. So the second specimen, 70 amperage, 17.1 voltage, and 1.9 meter per minute wire feed rate. So for the third specimen, 80 amperage, 17.3 voltage, and 2.0 meter per minute wire feed rate. So for the fourth specimen, 90 amperage, 17.6 voltage, and 2.2 meter per minute wire feed rate. So for the fifth one, 100 amperage, 17.7 voltage, and 2.5 meter per minute wire feed rate. For the sixth specimen, 110 amperage, 17.9 voltage, and 2.7 meter per minute wire feed rate. So for the seventh specimen, 120 amperage, 18.1 voltage, and 3.0 meter per minute wire feed rate. For the specimen number 8 is 130 amperage, 18.7 voltage, and 3.5 meter per minute wire feed rate. And for the last one, the last specimen number 9, is 140 amperage, 19.3 voltage, and 4.0 meter per minute wire feed rate. So for the machine selection for my study is, the first one is Fronius TPS320i. This is the welding machine for the robotic welding process, and the robotic system itself is RIB1520ID. So for data analysis collection procedure, for the visual test, first of all, I will prepare the welded specimens by cleaning them to remove any surface contamination, and then it will undergo a visual test, a visual inspection to assess defects on weld bit and root penetration, and then I will fill out the visual inspection plate reports form, and then I will also capture the image of the defects for future analysis on chapter 4, and then the form will be assessed by the experts in the field. Okay, for the destructive testing, the tensile test, the welded joints will undergo destructive testing to assess their tensile strength. And then the specimens will be put through a tensile testing machine until failure occur. And then the third one, last one, I will note the failure mode such as weld metal failure, base metal failure, or fusion line failure. So that is all from me for my PSM1 presentation, and thank you so much Dr. ERFY and Encik Zaki for listening, and I hope Dr. ERFY and Encik Zaki can correct me if my thesis is wrong, so I can repair it for my PSM2 next semester. So once again, Dr. ERFY and Encik Zaki, thank you so much.